All right, let's talk about how to calculate variance in Excel. We have a couple different ways, just like last time. We can use functions that we type in. We can use um, the data analysis tab. And we're going to go first through the functions, and then we'll talk about the data analysis tab. So if we want to talk about range, there's not actually like a range function. We can't type in equals range or something like that, unfortunately. But what we can do is we can use two functions, max and min. What max does is it returns your maximum value, and min returns your also maximum value. No, I'm kidding. It returns your minimum value. Come on. So you can, if you type this in, what I've got on the left side of your screen here, so we'll do this, equals max, and then, oh, I don't want score in there. There, that's 8. I can say equals min, scroll up, 3 is my minimum. And then, you know, here's what I could do. I could say, to find the range, actually, I could say 8 or A13 minus A14, and there's 5. Or I could type it all in together and say equals the maximum value of this range minus the minimum value of this range. And that's also 5. I mean, it should be. I'm glad it is. It would be weird if that didn't return the same value for some reason. This is how you would calculate your range. Now, yeah, you know, I know the way that I have it laid out here, you can totally eyeball it. You can just be like 8 to 3 because it's laid out, you know, in order. So you can probably do it in your head. But if you have a data set where they are not in order and you don't want to order them, then you can just use the max and min and make your life just a little bit easier. Okay, what next? Standard deviation. There's two different standard deviation formulas. You've got a stdev.s and an stdev.p. What do you think those stand for? If you said sample and population, you're correct. If you said summer and potom, you're wrong, and it's actually pronounced autumn. So sorry about that. Okay, so what we're going to do is we're going to come to this cell down here. You know what? I'm going to label these just so you know what these are as we go through. This is max, this is min, this is range. I don't think we need the second range. I'm going to get rid of it. Okay, so equals sign because, right, that's how we let Excel know that we're doing something with a formula. And then I'm going to type in stdev.s, and then what? Open parenthesis. That might have been backwards, but it's because of the camera. I don't know which, but it's the open one. Anyway, so stdev.s, this means we're taking the sample standard deviation. We want to scroll up. We want to grab all that data and hit enter. 1.76. Ba-bum. Now, what if this was a population? What if we had a population of 10? Seems unlikely, but we can see that these return different values. So we're going to do stdev.p, open parenthesis, and grab these values, hit enter, 1.67. So you can see again, we're being more conservative with our estimate of the sample standard deviation. We want it to be wider because we don't want a whole bunch of false positives, right? We want to overestimate the width of our standard deviation. And so you can see that. If this was a population, it'd be 1.67. It's a sample though, so the standard deviation is 1.67. 1.76. Cool. Okay, let's label these really quickly. Okay. Now we're going to talk about variance. I will show you two things. So the first thing, well, I'm going to show you actually two different formulas again for variance, because just like standard deviation, we have a sample and population version of the variance formula. You may not use this a whole lot. The equal sign to tell Excel that we're doing a formula. var.s to signify that this is the sample. And we're going to highlight all that data. 3.11. Now, what if this was a population? Well, then it'd be 2.8. So again, you can see that we're overestimating the size with the sample. Okay, one other thing. Remember, the standard deviation is the square root of the variance. If that's true, I should be able to go right here, and I should be able to type equals, because I'm going to give Excel a formula, and I'm going to say SQRT. That's the code for square root. And I'm going to put 3.11 into the square root, hit enter, and I have 1.76. These are the same number. So you can see that it's doing that, basically, right? The calculation for standard deviation is taking the square root of this. Okay, cool. So that's the sample variance. This is the population variance. All right. Yes, sample variance, sample for population, and, or I mean, sample variance, population variance, and then I guess that's all I had for code. That was quick, right? Quick and easy. Descriptive statistics. Here we go. With our analysis tool pack. You, by now, probably have analysis tool pack already set up on your computer, because we did the video prior to this one on central tendency. But again, if you don't have it set up, there's a different video that you can watch, and I'm walking you through how to get it set up. So for variance, standard deviation, everything like that, you want to go to Data Analysis Tool Pack, click on Descriptive Statistics, and click OK. I'm going to select A1 through A11 because I have a label. Remember, if you have labels, you got to tell Excel that you have labels. If you don't, it's going to freak out because it's going to think that score is a number, and it doesn't know how to deal with that. Okay, I'm going to click on Output Range because I want it to go in C1. And that looks like everything we need. Nope, sorry, we want Summary Statistics. Okay, so we're going to click on Summary Statistics. Now click OK. And here we go. Let's kind of widen these out so you can actually see what we're talking about. The mean is 6, which we know from before. The standard error, we'll talk about that later. The median is 6. The mode is 8. The standard deviation is 1.76. The variance is 3.11. And then kurtosis skewness, we'll talk about that later. The range is 5, and it also gives us our minimum and maximum. Sum and count. So you've got everything that we've talked about in this lecture right here from the Data Analysis Tool Pack. You could use all these values to compute these things multiple times, right? You could use the sum and the count to create the mean. You could use those to figure out everything. But why would you? Because it's right here. So that's how you get it with the Analysis Tool Pack. All right. One thing about the Analysis Tool Pack, you may have noticed this already, but right here, when we type in our own code, we can specify if it's sample or population, right? But analysis toolpack is just assuming that it's a sample. See that? So I've got two different standard deviations over here on the left, 1.76 and 1.67. The top is sample, the bottom is population. But if I go through the data analysis toolpack, it only gives me 1.76. So it's assuming that I've got a sample. Usually you're using samples when you're doing statistics. Not always, of course. And when you're doing the work for this class, of course, we're not always asking for sample or population. You have to know which one we're asking for. So it's good to know the code when you're dealing with a population. Again, if you're dealing with a sample, then Analysis Toolpack is going to give you all your information in just a couple clicks. So it's a nice way to go about things. Okay, that's all we need Excel for. So I'm going to make this a little bit bigger. Let's do a quick check on your knowledge. So go ahead. You can pause this after I ask the question and answer it. You can write your answer down. You can answer in your head. Shout it out. I can't hear you, but that's okay. I can hear you in spirit, I guess. So standard deviation is the distance from the what? It's part of the distribution. What part of the distribution? The larger the standard deviation, the what? The variability. Larger, smaller, sillier, one of those. Is the standard deviation sensitive to outliers? Remember, the mean is, but is the standard deviation also sensitive to outliers? What happens if the standard deviation is 0? What does that mean? And what is the sum of all the deviations from the mean? Go ahead and pause this if you want to hear any of those again. And I'm going to reveal the answers now. So the standard deviation is the distance from the mean, right? It's our measure of central tendency. We're looking for distance from the mean. The larger the standard deviation, the larger the variability. They are directly related. One is just the square root of the other one. So if one is large, the other will be large. It's just they're kind of on a different scale, basically, but directly related to one another. Yeah, standard deviation is sensitive to outliers, just like mean. And if the standard deviation is 0, that means all your values are identical. This is what we were talking about when we said if we had a scale of 1 to 10, how much do you like a thing, and everybody said 5 across the board, then our standard deviation would be 0. Everybody thinks it's just okay. Which, everybody thinks that that's how vanilla ice cream is, but look, man, vanilla can have a nice flavor to it. I know not all vanilla ice creams do. It's such a bad flavor sometimes, but good vanilla, oh man, good vanilla is really good. Anyway, that's my soapbox for the day, but give vanilla a chance. Good vanilla can be good. The sum of the deviations from the mean are going to equal 0. Now, this is before we square them, right? We haven't squared them yet. We're just subtracting each individual value from the mean. When you take those, what you get, those deviations from the mean, those should equal 0. Because, again, you have a central tendency and you have deviation to the right, you have deviation to the left. These should be symmetrical so that when you add them together, you get 0. You're right back at the mean. Okay. What affects standard deviation? Does the spread of data affect standard deviation? Does the sample size affect standard deviation? It's a yes or no question on both of these. And what does it mean if you have a smaller standard deviation? See, these are a little bit more conceptual than the last ones. So again, pause the video, and I'm going to reveal the answers now. So standard deviation is going to increase if your data is more spread out. This is our picture of tuna, the size of tuna, right? So if the brown boat at first is really spread out, it means it has a large standard deviation compared to the blue boat, which was more condensed. What about your sample size? Well, yeah, having a larger sample size means that your standard deviation is going to shrink. Why? Well, we have to go back quite a ways. We have to go back into a different lecture. Okay, think about this. The denominator, what the sum of the square deviations is being divided by, is n minus 1. So a larger denominator, even though you're subtracting 1, is going to create a smaller number overall, right? This is the difference of dividing 100 by 10 instead of 100 by 100. Dividing 100 by 10 leaves 10. Dividing 100 by 100 leaves 1. So a larger denominator is a smaller overall number. So a larger sample size is a smaller overall standard deviation, even though you're subtracting 1, right? And what does it mean if you have a smaller standard deviation? It means all your scores are closer to the mean, right? So the blue boat is a lot closer to the mean than that first brown boat that's really spread out. And so that's what a smaller standard deviation means. There's less variation in the scores that you're seeing. So if somebody is a really consistent sports analogy, golfer, yeah, a really consistent golfer. That works, I guess. They will have the same score on the same hole. They won't have a very large standard deviation. And if you have somebody like me, I don't golf very often. I am not consistent. Like, I will hit very long. My dad likes golf. This is why I don't actually really like it, but I go, father-son bonding, whatever. So I can hit really far. Sometimes it goes in the right direction. Sometimes it doesn't. If it goes in the right direction, hey, I got a low score. If it goes not in the right direction, then I have to hit it back the same direction, and then it's a really high score. So smaller standard deviation, the scores are closer to the mean. A good golfer would have a small standard deviation when you're looking at their score on the number of times they play the same hole. And somebody like me would have a really large standard deviation because sometimes it's like really good and sometimes it's really, really, really bad. So that's what a smaller standard deviation means. I think that is yes. We're just going to kind of review what we talked about. The formulas for standard deviation and variance are really similar. They both measure how the data are spread out from the mean, right? Really, the big difference is the standard deviation is in the units that you originally measured. So let's stick with golf. If we're measuring golf swings, hits, whatever, strokes is what they call it. Yeah, I know this. So we're measuring times we've hit the ball in a hole. The standard deviation is going to tell us in strokes, right? So like, let's say average is 4, standard deviation is 1. This means that it usually takes me 4 hits to get in, and a standard deviation is I'm usually either 1 shot less or more. It's in the same units that we used in the beginning. Now, variance, of course, is the square of the standard deviation, which means it's in units squared. What is strokes squared? That doesn't really make a lot of sense. And that's why we usually use standard deviation. It's more immediately meaningful to our brains because it's back in the same units, essentially. But again, they're directly related to one another. If one is large, the other's going to be large. If one's small, the other's small. One is just the square of the other. All right, again, central tendency. This is our center point of the distribution. Variability is how spread out the data are. That's it. Where is it, and how spread out is it? Again, here's our additional resources. You've got these slides, so you can take a look at these. And I will see you later in some videos about statistics.